How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at solutions and dilutions. So our objectives will be to describe how to perform dilutions and determine their concentrations. So, solutions and dilutions. What's a dilution? Well, a dilution is when a solution has water added to it in order to create a solution that is less concentrated. So looking at this picture, we start with very concentrated on the left side and then more dilute on the right side. So if you're like looking at it, if it's a colored solution, you can see it get fainter as it becomes less concentrated or more dilute. And what's happening is in the concentrated one, we have a lot of stuff packed into a given volume. And then as you dilute it and you add more water to it, it's spreading all that stuff out, right? So here you can see there's less concentration as you become more dilute. Yeah. During dilutions, we're changing the volume by adding water to our solution, resulting in a lower concentration. Now we know molarity is moles per liter, and what we're doing is we're increasing our liters, our volume. So if this is in the denominator, what happens to the molarity is it goes down, right? So it's like here we have something that's concentrated and we dilute it so it takes up more volume. And you can see we still have the same number of circles, the same amount of solute, but it's in a much bigger volume. So now it's less concentrated. Our moles, though, doesn't change. The moles stay constant over time. So the moles you start with is equal to the moles you end up with as far as what's dissolved, right? So if we rearrange that molarity equation to solve for moles, we get moles equals molarity times liters. All right, well, if the moles stay constant during a dilution, then my initial molarity times my initial volume has to equal my new molarity times my new volume because moles stays the same, right? So we have M1 times L1 has to equal M2 times L2 because the moles stay constant, which also means, you know, M1V1 equals M2V2. The only difference is I changed liters to volume. And the reason I did that is because as long as I'm using the same unit constant on both sides, it doesn't matter what the unit is. So this is a proportion. As long as you use, like you can use milliliters on both sides and you'll be fine. You'll still solve in terms of milliliters, all right? So you don't have to convert to liters. If you do, it's not going to give you the wrong answer unless you make a mistake. But yeah. So either form of it will work and give you the correct answer. So here's an example. 25 milliliters of 6 molar HCl is diluted until a final volume of 100.0 milliliters is reached. What is the new concentration? So they're asking for the new concentration. So let's see. I got M1V1 equals M2V2, and they want V2 by itself. So let me divide both sides by M2. And I get V2 equals M1V1 divided by M2. So let's see. My initial conditions is 25 milliliters of 6 molar. So I got 6.0 molar times 25.0 milliliters. And my, oh, they want, sorry guys, I goofed. Forgive me. They wanted concentration. So that's what happens. Sorry if I confused you. Anyway, so now I got to divide by the new volume, which in this case is 100.0 milliliters. And now you'll see why it doesn't matter that I didn't convert it to liters because I'm dividing by milliliters. So milliliters cancel out and I'm left with the molarity. So when I do this math, 6 times 25 divided by 100, I get 1.5. as my molarity. Cool. So let's say more practically you needed to prepare 100 milliliters of 1 molar HCl solution, but your stock bottle is 6 molar. How are you going to create this dilution? Well, first you have to determine how much 6 molar HCl will you need to make 100 milliliters of 1 molar HCl. So again, M1V1 equals M2V2. So set it up to solve for my initial volume. How much do I got to start with? I'm starting with the more concentrated thing, but how much of it do I need? Then plug in your numbers. I'm trying to get my new molarity to be 1 molar with a new volume of 100 milliliters, and my initial molarity is a 6.0 molar. So now I plug and chug, and I get about 17 milliliters. So now I know that's how much I have to start with. So how am I going to make this dilution? We'll measure out 17 milliliters of the concentrated stuff and add it to some volumetric glassware, like a graduated cylinders. So I'm going to take this 17 milliliters, I'm going to put it into this graduated cylinder, and then you just dilute it. You add distilled water until you reach the final volume that you're trying to get, 100 milliliters. And then you got it. You made that solution. So summarize. Can you describe how to perform dilutions and determine their concentrations? I hope so. Okay, bye.